my name is Paola Valdivia and I will present our work analyzing dynamic hypergraphs with parallel aggregated order hypergraph visualization. This is in collaboration with Paolo Buono, Catherine Plesson, Nicole Dufourneau, and Jean-Daniel Fequet. So, what is a hypergraph? A hypergraph is a generalization of a graph where links can connect any number of nodes. And how is it different from a normal graph? Why do they need a special visualization? Let's see how can we represent a who knows who graph using a node-link diagram. In this normal graph, we have 4 people, and we have an edge if 2 people know each other. We see that everybody knows everybody else. Now, let's look at the hypergraph. Nodes are the same 4 people, but now each hyperedge represents an article. The first one was written by Catherine and Jean-Daniel, the second one by Catherine and Paolo, and a third one and a fourth. Sadly, it looks exactly the same as the who knows who graph. So how can we reveal hyperedges? One approach will be to use a different color for each article. Or we can represent articles as sets. Now, you can imagine that with a higher number of authors and articles, we could easily run out of colors. The representation will start to look cluttered, and making sense of the visualization will become challenging. Another way of visualizing hypergraphs is by using a bipartite network, where a different encoding is used for each type of node. In this case, the nodes are authors and articles. But let's now describe our proposed technique to visualize hypergraphs. And later we'll see what is the advantage over the other representations. Firstly, we align all authors' names to the left and represent each article as a vertical line. We add a .in to indicate that the person is a co-author of this article. For example, this article has Catherine and Paolo as co-authors. We add 2 more hyperedges to represent the other articles. And now we have represented the 4 articles without overlapping. And we can then examine connections between all co-authors. Even more, assuming all of these articles were published in the same year, we can group them in a time slot, called time 1. And we can add more time slots next to this one to represent a dynamic hypergraph. Using our representation, called PAOHVis, we can analyze in detail connections and changes in the co-authorship relations over time. Let's see now a case study to see how we can use PAOHVis to analyze a dynamic hypergraph. This case study was led by Nicole, a French historian. She is interested in analyzing the role of a merchant, Marie Boucher. There is no historical information about Marie Boucher, but she is mentioned in 59 legal documents from the 16th and 17th century. The dataset of Marie Boucher was collected, processed, and analyzed by Nicole. We will see how she performed her analysis and how she can perform the same analysis using PAOHVis. But first, this is an example of a legal document of the 17th century. The historian needs to extract the information and process it to be able to have a clean dataset that can be used by computer tools. As you can imagine, this is a long and complicated process that produces medium-sized networks of about 200 nodes. After that, the historian performs a long, careful, and detailed analysis on this dataset. The historian had already analyzed her dataset with the help of 2 representations. The first one was a bipartite graph where she can see the connections between documents and persons, but no temporal information. The second representation was a time arcs visualization made in the online tool, the Historian, where she can see the connections between pairs of persons over time, but the document information is lost. That means she cannot tell if 2 arcs represent the same document. Using PAOHVis, she has the list of merchants at the left, and she can see each document, the detail of who was mentioned in each document, and the temporal information. In this case, each time slot represents a year. Let's go back to understand how PAOHVis worked with a simplified example. In this example, the user colored the nodes by family and selected the first node. The user sees that there are two families, Colin and Dos Santos, and they can further see that Elise has connections with all of the 13 people in this dataset, and then she is mentioned in 14 out of 19 documents. Okay, now let's go back to our case study. In this dataset, we see that there are 59 documents, represented by the hyper edges. These documents correspond to a 22-year period. We have 181 people, where only 38 that appear in more than one document are listed. The other 143 people are hinted as drips, which are those smaller circles. When we hover over the hyper edge, all the names appear, so users can explore in detail who appears in each document. So, as I said, in the past, the historian has used this time arc representation to explore the connections between persons. But the information of each document was lost. So she made the assumption that two persons connected the same year appear only in one contract. However, using PAOHVis, she discovered that there were multiple documents involving these people in the same year. In the end, the same analysis can be done more accurately using PAOHVis. Another thing that she observed was that the previously identified stages in the merchant life of Marie Boucher are pretty evident using PAOHVis. As she observed, at the beginning, Marie Boucher had only business in France. Later, she started transatlantic business, and her third period was an expansion phase, when she associated with Huber and Tom to form the Marie Boucher and Huber and Tom company. In her words, this is a tool to verify a hypothesis. It gives ideas and structured thoughts. It provides narrative support and is a useful communication tool. Now, let's look at some useful interaction techniques implemented in PAOHVis. We can highlight, select, and filter edges. By clicking on Marie Boucher, I select her and filter the edges to see only Marie Boucher connections. I can reorder the nodes using different strategies. By default, the names are ordered chronologically, which means that people who appear in the earliest documents appear on the top of the list. Or we can order by group. In this case, people from the same family are grouped together. The option of showing group names on the left allows us to edit the names and also collapse the groups to see connections between groups. Like in this case, the interaction between the two families is clearly shown. Notice that each aggregated hyperedge remains a hyperedge. To identify usability problems, gather feedback, and improve PAOHVis, we performed a usability study with 9 participants. It consisted of 2 phases, discovery and task phase, each one lasting around 20 minutes. During the discovery phase, participants received no training and were asked to describe what they were seeing, and then they were asked to freely interact with PAOHVis. After that, they performed 6 tasks and provided feedback and suggestions. After each participant, we fixed the usability issues. During the discovery phase, we used a small co-authorship network from the ILDA team. At the beginning, we did not give access to the interactive features. Still, participants figured out the layout without training. After they could use interaction, they all understood the color coding and that drips represented filter-out authors. An example of problems we noted and fixed was that the terms vertex and hyperedge were confusing, so we replaced them by custom terms loaded with each dataset. For example, instead of vertex, we say author. Instead of hyperedge, we say publication. Some participants were lost after filtering, so we added a simple animation to clarify what was being filtered out. For the second test phase, we use a larger co-authorship network with 20 semesters of the publications of the PAOHVis and the ILDA team. To give an example, the third task was, looking at Petra's network, are there papers with the exact same co-authors in different semesters? Tell me the names. One of the participants' approach to solve this task was to first locate Petra and then filter out her network. After that, the participant highlighted similar edges approaching the cursor to each line. Like in this case, all edges which include Petra and Tobias Eisenberg, Michael Sedlmeyer, Thorsten Moller, and Jan Shen are highlighted, which is a possible answer to this task. In fact, the possibility of highlighting similar edges was added after the fifth participant and was used by 3 of the remaining 4 participants. In summary, participants were able to interpret basic features of PAOHVis with no training. More complex features need some training, for example with video demonstrations. It was also interesting that participants liked the filtering feature because it reduced clutter, which is coherent with our intuition that PAOHVis is good to analyze small networks in great detail. To conclude, PAOHVis allows to display dynamic hypergraphs with no overlap or crossings, making it very readable. PAOHVis shines with mid-size graphs and allows detailed analysis. Drips and filters go a long way to deal with larger datasets, but compacting and grouping helps to scale further. So what's next for PAOHVis? Clustering is important to our users. That's why we developed an approach for clustering that is presented in a VAS session. We will continue to develop PAOHVis and add features that are useful for our collaborators, mostly social scientists. Next steps include, for example, highlighting differences between time slots, visually encode node and hyperedge attributes, and dynamic clustering. PAOHVis is available at this address. Thank you.